This is a video on section 5.6 on solving trigonometric equations. So this unit relies heavily on our knowledge of solving for theta, given various sine and cosines of that angle from chapter 4 or unit 4 in trigonometry. Also, it's a good review of our algebra skills, and so it's really a combination of both. So as a warm-up, let's just sort of go back to what we did in chapter 4 when we were given a question such as sine of theta is equal to minus 2/3. What is theta between 0 and 360? So one of the things that we want to remember is that in order to get theta, we always need to get what the reference angle is. So we can never solve for theta directly. We can only solve for the reference angle. And again, in general, if we have the sine of how do we get the sine of the reference angle? That's going to be the same thing as the absolute value of the sine of our angle of sine of theta. So in this case, we want to solve for sine of alpha. So sine of alpha in this case is going to be 2/3 because that's the absolute value of negative 2/3. So alpha is the sine inverse of 2/3. So that makes alpha, if we plug that into a calculator, rounding to the nearest degree, that's going to be 42 degrees. So we're told that the reference angle is 42 degrees. So I always like to draw a quick grid on our side using cast as a reference to figure out where this angle should be. So since the ratio is negative for sine, that means our angle must be in either the third or fourth quadrant. And what we did over here was that we solved for alpha. So in this case, the reference angle here would be 42 degrees, and the reference angle here would be 42 degrees. So that makes one possible answer for theta is this angle here. So that's theta 1. In that case, that's 180 degrees plus 42. So that's 222 degrees. And the right answer for theta 2 would be this purple, would be that angle over here. So that would be another possible answer for theta. So in this case, that's going to be 360 degrees minus 42, which is 318 degrees. And the nice thing about trigonometry in some sense is that when we have our calculators, we could actually check our answer. So if we plug into our calculator sine of 222, we should get roughly negative 6.666. And likewise, if we do sine of 318, we get exactly the same answer. Okay, so again, the main success criteria, the main thing that we want to be able to do after this section is to solve an equation that involves trigonometric ratios. And let's do this through various examples. So our first one is relatively kind of trivial. Here we're given cos of x is 1. So we know that that's going to be a peak. And if I sort of draw the cosine graph here, we notice that the peak happens at both 0 degrees and 360. So this one actually has two answers because we want to answer for x between 0 and 360 inclusive. So in this case, x is going to be 0 degrees or 360 degrees. The next question involves a little bit of algebra. So what we always want to do is we want to isolate for a trig ratio first before we actually solve for the angle. So in this case, we want to divide both sides by 2. So in this case, we want to divide both sides by 2. So here we're going to get sine of x is equal to negative root 3 over 2. So this is almost very similar to the problem that we had in the warm-up, where we can't get for x directly, but in this case we could see what alpha is. So we need to determine what the reference angle is. So that's going to be sine of alpha is root 3 over 2. So alpha is going to be the sine inverse of root 3 over 2. Hopefully we recognize that this is an exact ratio. So in this case, alpha is 60 degrees. So I'm going to quickly draw my grid, look at my cast. again, sine is negative, so sine is going to be quadrants 3 and 4, and we're told that basically our reference angles in each of those quadrants is 60 degrees. So theta 1 would be, again, it's very similar to our warm-up, 180 degrees plus 60, so that's how we get the answer for quadrant 3. We need to add 180 to our reference angle, so that's going to be 240 degrees, and our second answer is going to be 360 degrees minus 60 degrees, which gives me 300 degrees. So those are two answers. Moving on, so we got something that's a little bit more tricky, only because it's now we have sine squared. So here we're going to have to do some factoring. One trick that we can do to sort of see what we need to do to factor is that we could let a variable, in other case, let me let t equal to be sine of x. So in this case, what we get is really t squared minus 1 is equal to 0. This step helps us to see what we need to factor a little bit better because we don't actually see the trig ratio, so we're not confused in that sense. So this is a difference of square. So here this factors to be t plus 1 is equal to, times t minus 1, that's equal to 0. So that implies that t plus 1 is equal to 0, or t minus 1 is equal to 0. So in this case, t is equal to 1, and t is negative 1, and t is equal to 1. But unlike quadratic, we're not actually done because we actually have to plug sine of x back in for t. So let me do this off to the side. So here we're saying that sine of x is equal to minus 1. So x is the sine inverse of minus 1. And we know that here minus 1 is going to be the trough of sine. And in this case, that happens at, and I like to draw a quick sketch of what sine looks like, and I'm going to draw a quick sketch of what cos looks like. So in this case, it's hitting the trough at 270 degrees. The other one, we have sine of x is equal to 1. Oops, not 6x. 6 is equal to 1. Sine of x is equal to 1, and that means x is the sine inverse of 1, and that happens at 90 degrees. So that's your answer for the second one. So the second example is our 2b is very similar. In this case, I'm gonna bypass the let statement and putting a variable in, but here in this case, I can see that I could factor out a cos. So this is really going to be cos of x. And when I factor out cos of x, I'm left with 2 cos of x minus 1 is equal to 0. So that implies that cos of x is equal to 0, or 2 cos of x minus 1 is equal to 0. So in this case, cos of x is equal to 0. Well, where does cos hit 0? Well, actually hits in two spots, right there. Let me do this in red. Right there and right there, which is 90 and 270. So our first answer, so in this one, x is either 90 degrees or 270 degrees. So that gives us two answers. So that's another thing we sort of need to remember when we're given these trig equations, is that for one particular one, there's a good likelihood that there are two answers. So given a quadratic, there's probably 4 answers for a final answer. So let's look at the second one, where we have 2 cos of x minus 1 is equal to 0. So that means that really 2 cos of x is equal to 1. So cos of x is equal to 1/2, dividing both sides by 2. So that makes, so again, we have to go off and we can't solve for x directly, but we want to get the reference angle. So cos of alpha is 1/2. So in this case, alpha is cos inverse of 1/2. So alpha in this case is 60 degrees. So because cos, the original equation, cos is positive. So I'm running out of space. Let me do that over here. Cos is positive. So that means that happens to happen in quadrants 1 or 4. So that implies that theta, or sorry, x, dealing with x, is either 60 degrees or 300 degrees. Because in this quadrant, alpha is there. And so that's how we get our angle. It's going to be 360 degrees minus 300. So our final answer for this one question, so it's rather long, it's going to be 90 degrees to 207 degrees, 60 degrees, and 300 degrees. In other words, if I could plug in either for x, either 90, 270, 60, or 300 into my original equation, that will make that equation true. Our next example, again, involves some factoring. So this one looks like it's a little bit more tricky to factor because it's a trinomial. So I might let t equal sine of x here. So in this case, I'm going to get 2t squared minus t minus 1 is equal to 0. If we want to do quickly PSI on that, we could, but the numbers are relatively small. So here, this is going to factor to t and t. Here I know that I want a negative term in the middle, so that means I need a negative 1 because negative 1 going to be multiplied to 2 is going to give me negative 2, and that gives me a positive 1. So here, this implies that, so I'm going to do one step here and replace t with sine of x at the same time. So 2 sine of x plus 1 is equal to 0, or sine of x minus 1 is equal to 0. So we'll have to solve for each of those now. So here I'm going to work at 2 sine of x is equal to minus 1. So dividing both sides by 2, that means sine of x is negative a half. So again, we can only get x by working with the reference angle. Maybe I'll do this over here. Sine of alpha is a half, so that makes alpha going to be 30 degrees. So my quick sketch of the grid of my quadrants using cast. Again, sine is negative, must be in those two quadrants. Alpha in this case is 30 degrees. So in this case, one answer, or x, I keep writing theta, x would be 180 plus 30 degrees, which is 210 degrees. And our, again, second answer, because sine is negative in the fourth quadrant, is going to be 360 degrees minus 30 degrees, which is 330 degrees. Okay, fortunately the other one is a little bit shorter to do. Let me do that over here. Sine of x minus 1 is equal to 0. That means sine of x is equal to 1. So in this case, sine hits 1 when x is 90 degrees. So therefore, our final answer is that x could be 90 degrees, 210 degrees, and 330 degrees. Our next question, for A, actually this does not require any factoring. We just have 4 sine of x minus 3 is equal to 0. So the only reason why this one is done later on is because it's almost like our example up top, where it's not going to be exact ratio. So let's work this out. I'm going to add 3 to both sides, because again, you want to isolate for your trig ratio. So in this case, we have 4 sine of x is equal to 3. Again, divide both sides by 4. So I get sine of x is equal to 3/4. Again, we can never get x directly. We always have to get the reference angle. So in this case, we're going to say sine of alpha is 3/4. So alpha is going to be the sine inverse of 3/4. Plugging that to our calculator, the sine inverse of 3/4 is roughly 49 degrees. So nearest tenth of a degree. So it's actually 48.6 degrees. So drawing a quick sketch of sine. Sorry, drawing a picture where sine is positive. So using our cast, sine is positive in the first and second quadrants. So that means theta 1 is just strictly 48.6 degrees. And theta 2 is going to be this one over here, which is 180 degrees minus 48.6, which is 131.4 degrees. So therefore, x, I keep using theta again, but x is 48.6 degrees or 131.4 degrees. Okay, the next one is probably the most trickiest one of all because it does require factoring, and again, here our equation is not equal to 0. So in order to factor, in order to solve for any quadratic, we need to one side equal to 0. So I'm going to add 2 to both sides. So do this on the side. So here you get 3 cos x squared. Sorry, we're going to get 3 cos squared x plus 7 cos of x plus 2 is equal to 0. Again, this one's going to be a little bit harder to factor, so I'm going to break this up a little bit. I'm going to let t equals cos of x. So here we really have 3t squared plus 7t plus 2 is equal to 0. We could use the product sum integer to sort of factor this because we have to decompose. So the product here is 3 times 2, which is 6. Our sum is 7. And our integers are going to be 6 and 1. So we're going to decompose this to 3t squared plus 6t plus t plus 2 is equal to 0. We're going to common factor out those two terms together. So the first part here, I'm going to factor out a 3t. So I'm left with t plus 2. And here I'm just going to factor out a 1. That's all I could do. So I'm left with t plus 2 there is equal to 0. And here we're going to common factor out a t plus 2. And we're left with 3t plus 1 is equal to 0. So in this case, each of the factors has to equal to 0. And at the same time, I'm going to replace t with cos of x. So here we're going to say cos of x plus 2 is equal to 0, or 3 cos of x plus 1 is equal to 0. Here, so let's work on the left side. On the left equation, cos of x plus 2 is equal to 0. So cos of x is equal to minus 2. In this case, the lowest value for cos can only be negative 1. So in this case, x has no valid values to make that equation true. So we can sort of ignore it. On the other side, or sort of the other equation we need to solve for, we're going to get 3 cos of x is equal to negative 1. So cos of x is equal to negative 1/3, dividing both sides by 3. Again, here, in order to get x, we need to solve for alpha. So cos of alpha is going to be a third. So alpha, in this case, is going to be the cos inverse of 1/3, approximately 70.5 degrees. So I'm going to run over to the next page, or actually, you know what, let me finish that over here. Let's look at cos. So cos here was negative. Cos here was negative. So using cast, that means that theta or x must reside in those two quadrants, 2 and 3. And we're told that alpha is 70.5. So x1 in this case is going to be 180 degrees minus 70.5, which is 109.5 degrees. And x2, for quadrant number 3, we need to add 180 to alpha. So here's going to be 180 plus 70.5 degrees. So that makes x2 250.5 degrees. Okay, so those are all the examples that we have on the sheet. So hopefully that's sufficient for you to go off and do your homework, which is on the handout that's provided.